Okay.
Now he's going to present his screen.
For an iOS app.
Apparently the dongle is broken. Yes, hopefully.
Give them like their knowledge in the game.
Should be okay.
What's their business model? Like, we're on apps.
How do I go full right here?
Sorry?
How do I go full screen?
Oh,
There's a button somewhere.
we just have to. So you're in Chrome.
Well, just put. I guess I go full screen with.
Yeah, probably. It's probably going to be good enough. I mean, that's. In fact, they'll have that on the screen. Okay, so we just need to get you on Apple TV.
Or is it?
Oh, so he's just plugged directly in.
It should work when it plugs in.
Alright. Once I start
Good.
presentation mode here. Yeah, that's perfect.
Like $1,000.
I don't think there's any way to
No,
hide it.
that's
Control.
probably good enough, honestly.
All right, so Art's going to talk about that, your Google Hangout connection. So it should be fun. Sorry for the delay. Have fun.
Thank you. All right, thank you everybody for coming tonight. Real quick, this is a joint meeting between Milwaukee JS and the Milwaukee Sencha user group. So if you're from one of the other groups, sign up for the opposite group on Meetup because there's lots of good stuff in both places. We're just consolidating our efforts today. I've got some Sencha stickers and Sencha pens free to everybody down here. The stickers stick to anything, and the pens will write on paper. So that is fascinating. And if you've RSVP'd for Milwaukee JS tonight through that meetup page, you'll be eligible for a raffle at the end for some other cool stuff I've got up here. So today we're here to talk about debugging your apps with Google Chrome and Sencha. Let me start. Yeah, that's better. Let me start by asking a couple of questions here. Who here has used Chrome developer tools? Just about everybody. Awesome. Okay. Who here has tried building a Google Chrome extension? 1, 2, 3, 4 people. Okay. How many of you have heard of Sencha? Most of you. And how many of you have actually built an application with Sencha? Good. Okay, cool. So who am I? My name is Art K. I am the Developer Relations Manager at Sencha. I live in the northern Chicago suburbs, and by northern suburbs I mean just south of the Wisconsin border. So equally part of the Milwaukee suburbs if you're going by pure distance to a major metropolitan area. But as interesting as that is, you can follow me on my website, akawebdesign.com, or catch me on Twitter. And today's presentation is in no way a sales pitch of Sencha. I'm really here to tell you guys a story about how I built a Google Chrome extension because I find it to be incredibly useful. And what I would like to do would be to kind of walk you through who Sencha is in about 5 minutes. And then we'll dig into Chrome DevTools at a pretty high level, get into a handful of deeper topics. We'll talk about how you would build your own Google Chrome DevTools extension. And finally, I'm going to show you an example of a Chrome extension I've actually built, which is called App Inspector for Sencha. So let's take a quick look at who Sencha is. And again, just pointing out, I do work for Sencha. I drink our Kool-Aid. So definitely expect this to be slightly biased. But for those of you not familiar, Sencha is a technology company based in Redwood City, California. Every single thing we do revolves around HTML5. We've been involved with the web since 2007 when we were first founded. We are venture capital backed by Sequoia Capital, Jafco Ventures, and Radar Partners. So if you're interested in any of that, certainly check out our website. I'm not here to really dig into that. And just some quick hit stats if you're not familiar with Sencha. We've got 2 million developers worldwide, more than 10,000 enterprise customers, and we like to brag that 60% of the Fortune 100 use our products. So I'm telling you this because I want you to understand Sencha is not just some fly-by-night company building frameworks. We've been around for the better part of 7 or 8 years. We work with some of the biggest companies in the world, and we really focus on building enterprise business applications as opposed to consumer web applications of any flavor. So that's one distinction I want to make, is that if you're looking to build the latest Angry Birds, Sencha is not the company you want to work with. But if you're looking to build business applications, we're certainly going to be at the top of your list. Sencha's platform consists of essentially 3 parts. We help businesses design, develop, and deploy applications. So we've got a tool called Sencha Architect, which is a visual application builder, kind of like a really light version of an IDE, but specific to our tool set. We have EXTJS and Sencha Touch, which are our 2 JavaScript frameworks. And finally, Sencha Space, which is a secure HTML environment helping enterprise companies to manage and deploy their applications across every device. So, again, if you're interested in the sales pitch, go to Sencha.com. I'm not here to really sell you on Sencha's products today. So what I'm getting at in my introduction to Sencha here is that Sencha is all about building web applications for business and enterprise that run on any device. So anything from my apparently very old MacBook Pro, old Windows machines, to your latest tablets, whether they be iPad or a Surface tablet, some really exotic phone, maybe running something like WebOS or Firefox OS. Our frameworks help you build applications that run across all of these different devices. That's really one of the main selling points for Sencha. And just to take a step back and tell you a story about where I'm coming from, I'm currently the developer relations manager at Sencha. This is a role I've been in for about 4 months, and prior to that, I worked in our professional services team for 3 years. Before that, I held a variety of jobs in various companies building web applications, and so yada yada yada. I have, up until very recently, spent 50 hours a week, head deep in my IDE and my browser. Right? All I've done is web development for the last 10 years, and where I got into building Chrome extensions was in the Sencha professional services world. I would go out into companies like Bank of America or Citibank or a variety of other really large Fortune 1000 companies and help them build business applications. And when you get into your browser's developer tools, in the last 12 to 24 months, every latest version of any browser has really good developer tools, but historically they were terrible. And even now, having something like Google Chrome's developer tools, while they're as awesome as they've ever been, if you're developing an application with either a framework that like Sencha or maybe like Angular or Ember, or if you're an enterprise company, chances are you have your own libraries that sit on top of whatever framework you're using. Chrome Developer Tools doesn't give you any information about your application. There's a saying that I like, which is just because your tests pass doesn't mean your application works. And at the end of the day, Chrome Developer Tools tells you a ton about your code, but tells you next to nothing about your application. And so what I'm going to end up showing you today is the process by which you can build your own extensions to intelligently dissect applications that you're building. So let's take a quick look at Chrome DevTools. So Chrome, is a little history lesson, was first released in 2008. Can anyone tell me when the iPhone was first released? 2007. So, it's hard to think about that now, but the iPhone is actually older than Google Chrome, which really sounds like, we're so used to using Google Chrome. I'm so used to my iPhone. To think that this is only like 7 years ago really kind of is shocking when you step back and look at how far we've come. Google Chrome is currently using 6-week release cycles. So every 6 weeks, whether you like it or not, Chrome is going to push an auto update. So you're always running the latest version. And Chrome's been really good about not breaking things for the most part, but this is kind of something to keep in mind. We're currently at version 35, but by the end of the year we'll be version 38 or something like that. And staying on top of the new features, what they change, not only in the browser but in the developer tools themselves, really hard to stay on top of. When you factor in, Firefox is doing the same thing now. Internet Explorer is basically doing the same thing. It makes our lives as web developers more and more challenging to stay on top of what's happening here. The basics of Chrome Developer Tools really hasn't changed much since Chrome first launched this feature. Things like the Elements tab, your Network tab, JavaScript sources, your Resources tab, and your console. These things have been around for a really long time and are fairly easy to understand. I'm just going to jump quickly into my browser and let me pull open an application just to give you an idea here. So the Elements tab, I can mouse over any element here on the screen and it'll highlight, you can see, the various CSS classes that are on the screen. If I'm down here in the bottom, it'll tell me what styles I'm using. Over here on the bottom right, we can see a little diagram of what my heights, widths, padding, margins, all of my CSS properties. More recent features, things like your event listeners, if you have any DOM breakpoints. There's a variety of bits here, but at a high level, the Elements tab hasn't changed much over the years. It's really pretty straightforward. You're just looking at a live view of the current DOM tree. The Network tab, again, hasn't changed a whole lot. If I refresh here, we'll see all of my JavaScript files, CSS, images. These all show up, and I can filter down by certain types. It just helps you figure out what resources are being loaded and when, how long things take, how big they are. It's certainly a very useful tab. As a web developer, I find myself more often in my Sources tab, and that may be more of a reflection of the fact that I work for Sencha, and Sencha's JavaScript frameworks are more focused on JavaScript development than HTML development. In fact, if you're building a Sencha application, you will very likely write next to no HTML. So that's very different than, say, the world of AngularJS or perhaps Ember.js to some degree. So in my line of work, I spend all of my time in my Sources tab, and here we can dig down into any JavaScript files that have been loaded, and then set breakpoints and do all kinds of fun stuff here. Resources tab, very similar in that it shows me if I've got any items in local storage, if I have any cookies that have been set, or application cache. So that's pretty useful. And then last but not least, your JavaScript console, where I can literally type any, and it'll execute in the context of a web page. So pretty sure I haven't told you anything you didn't already know at this point. So let's move on. So Chrome Developer Tools, if I had to guess, probably has in the ballpark of like 2,000 individual features, most of which are not well documented. So some of these items here, like your audits tab, timeline, and your profiles, has anyone played around with these 3 tabs in Chrome Developer Tools? Handful of you, okay. So these are really easy to find. Like, you jump back here, you can see I've got my timeline, my profiles, and my audits. These are features that are not hidden, but most people really haven't used every day. I'm going to start with audits, where if I hit run at the bottom, it gives me an output of things Chrome believes, or I guess by extension Google believes, I should change to optimize my application for the web. So has anybody ever used YSlow, plugin for Firebug? It's nearly identical to YSlow. It tells me I need to combine my external JavaScript because I've got multiple resources served from the same domain. If I'm leveraging browser caching, or if I'm using gzip, if I've put styles and scripts in the correct order, if they're at the bottom of the page versus the page header. There's about I think 20 to 50 best practices that the developers at Yahoo came up with maybe 10 years ago for high performance web pages. And the audits tab for Chrome Developer Tools essentially just checks your site to see if you're adhering to those best practices. So that's certainly useful. The timeline is another cool feature where I'm going to hit record, and I'm going to refresh my page, and then I'll stop recording. What I'm looking at now is a view of my browser frames, but if I unclick that, you'll see an actual millisecond by millisecond view of what's happening in the application. So it's recording everything from events. I'll show you the filter here. Events, scripting tasks, if resources are loading, when the browser physically renders things or paints things to the screen. These are very interesting metrics that help to really dissect application performance at a minute level. So as an example, if I clear this, I start recording, so I'm going to undo my events here, and if I just pull that down, we'll see that in purple, and there's a couple of frames in green, that the browser has physically re-rendered something to the screen. So if I wanted to inspect this, I can dive into it, and it'll tell me, purple had an update layer tree, then there was compositing layers, and there's not much official documentation from Google on how to use the timeline, but if you search YouTube, there's a series of really good presentations by the DevTools team, as well as a variety of other people from conferences like JS Conference, a variety of others. So at some point you can even see where it's recalculated the style, and it'll tell me what line of JavaScript caused that to happen, as well as giving me a stack trace. So a good example would be if when I was scrolling my page here, if all of a sudden the browser froze, or if I was having really jaggy animations, you'd be able to use their timeline, find the point in time where different repaints or rendering operations are happening in the browser, and you can try to optimize the way in which your code runs. So maybe you shouldn't be using CSS backgrounds when you hover over something, because I'm just going to repaint that to the screen. So there's a wide variety of things to account for there. Last but not least is the Profiles tab. And how many of you have actually looked at your JavaScript CPU profile for an application? A couple of you. How many of you have taken a heap snapshot? How many of you actually know what the heap snapshot is saying? Okay. I'm going to put my hand down on that one too, because honestly, there's not much useful information at first glance in your heap snapshot. So what the heap snapshot is, it takes a look at the memory of your current browser tab and helps you analyze every piece of memory that's currently allocated. So you can look at things like, I've got a closure here, and there's got a variety of functions in here, and there are certain objects that are stuck in memory as a result of being inside of a closure. Or in some cases, you can see things that are scheduled for garbage collection. The general idea with taking a heap snapshot is that you would take one snapshot, then I would do something else on the screen, and then I'd come back here and take a second snapshot and see what has changed. So perhaps you're looking for memory leaks where you've got orphaned DOM nodes somewhere, or you've got objects stuck in a closure that you forgot to set to null. Really advanced stuff, and you can do a comparison, so you can see that between these two snapshots, snapshot 2 has 6,400 additional delta values, whatever that actually means. So presumably, if you were a browser memory snob, this tab would be particularly useful. Again, in my line of work, I actually do use the JavaScript CPU profile far more often than you might think, where what this will do, I can start recording and move around the application, stop recording, and depending on which view you use, in this case I'm using a heavy or a bottom-up view of my CPU profile, I can see what the browser is actually doing. I'm sorry, is this terribly small? Somebody can...
A little bit.
Feel free to shout out that I'm going too fast or not making things large enough. But so in this particular case, in my CPU profile, if I hadn't mucked this all up here, so for 87% of what I just recorded there, the application runtime is sitting idle, which is pretty good. Program means the browser was doing something unrelated to your application. So that was another 5%. So like 92% or 93% of my application runtime here has nothing to do with the application I wrote. So that's generally pretty good, because how do I say this? If you're building a HTML5 app and you're using more than a fraction of what the browser's runtime memory is, you're really doing something wrong. There's something to watch out for. But since we're in a bottom-up view of these calls, we can see that the next heaviest call is coming from a get-bounding client rect function. So I can physically dig into this and see, the bits inside that function that are getting called are these two methods, and the one on top is always heaviest, so maybe I would dig into that one, and you kind of dig into this call stack to figure out where the root of your JavaScript profiling is starting to take up a lot of memory. So a real-world example might be if you're doing a sorting algorithm and you're using the wrong algorithm. You could use CPU profiling to help you figure out areas to optimize. And then you just dig into the stack here. It's got links into your JavaScript source. So that's actually a very useful feature. But again, unless you're doing some really advanced digging into your JavaScript source code, you might not need to use that. Okay, so those are the advanced features, and again, there's probably like 2,000 other features of Chrome Developer Tools. So many that they ran out of space to physically show them to you. So I like to call these things the hidden gems of Chrome Developer Tools. Because you really have to go digging into your settings to figure out how to just turn them on, let alone use them. So I'll come back to that slide, but let's start with our layers feature. So this is a Sencha Touch application that I built to demonstrate how to do some CSS3 transitions. So what it is, it's basically a shape that rotates a bunch of faces or widgets, pictures, whatever I want to put into my application, and rotates them around. If I want to, I can add things on the fly. I can scroll them like that. I can actually start typing into form fields. So it's a very whimsical example. And I say that because, again, Sencha is focused on building enterprise business applications. I really don't think you'd ever use this in a business app, but prove me wrong. But in any event, what you might want to do with Chrome Developer Tools is figure out if your CSS3 transforms, in this case, are being pushed into the correct shape. And what we can do, up here in the upper right, I've got this settings button I can click on and go to things like experiments. So this is all stuff that's built into Chrome Developer Tools, but they're just hiding from you for whatever reason. So if I enable Show Layers panel, and then we have to refresh this, or sorry, close Developer Tools, then we open it. Now I get this fancy Layers tab, which I can move around. Sorry, my computer's choking on the video stream right here. But in any event, there's a three-dimensional diagram of my HTML application. So I can actually move it around as I update the DOM. You can kind of see it's trying to update it. Like I said, it's just choking on the video feed here. But in any event, that's a really cool feature that you would never have known existed unless you really dug into Chrome, the developer tools. Another awesome feature, let me just somewhere else. Let's go to my Elements tab. Again, if you're like me and you're a big JavaScript nerd, so much that you want your console open at all times, at any time inside Chrome DevTools, you can just hit Escape. All of a sudden, a console pops open. So I can type whatever I want in here. Hello world. The best part, though, is it's got this feature called emulation. So that if you're building an application, maybe you're working on an HTML5 app that you want to deploy to mobile devices, I can say, well, I'm going to target the Apple iPhone 4, emulate it. And what it'll do, it'll change the dimensions of your screen so that you know what it will look like when you render the application. In my case, I have to refresh And there we go. The best part is that it now translates touch events into the application rather than mouse events. So rather than clicks, you get tap events fired. So that's extremely helpful for when you're debugging your HTML5 apps on mobile. Under rendering, there's a really cool feature called Show Paint Rectangles, so that as I'm interacting with the application, it will highlight in green the areas of my app that get repainted by the browser. So again, this goes back to my comments on the timeline tab. If you're really running into like jaggy animations, turning on Show Paint Rectangles or composited layer borders. If I'm interested in how many frames per second my application gets, I can turn that on as well, and I don't know where to just put that. There we go, at the top here. It'll tell me how many frames per second my application is running at. So we usually want this to be as close to 60 frames per second as possible. In my case, I'm hovering in the upper 40s, mid 50s. So this application is pretty good to go for mobile devices. And there's all kinds of other stuff here. I'm not going to go through every single feature. Oh, last but not least, again, because I'm a JavaScript nerd, under sources, we can do things. Excuse me. Do things like pause on exceptions, so that if I dive into my IDE and show you one I've already got open, and I say I'm going to put in some junk JavaScript here so it'll throw an error. What will happen when I refresh it? So because I'm calling a function that doesn't exist, when I go to my console, we're going to see I get uncaught reference error. Foo is not defined. So that kind of sucks because my application is dead. There's nothing I can do about it. Luckily, I get a nice pinpoint of where it breaks, but maybe I want to debug and find out what the stack trace was. So there's this little stop sign looking thing I'm hovering over. Or if I hit it once, it turns blue. And it'll pause anytime it runs into an error. So now I'm stuck in my debugger. Now I can debug what my call stack is. I can figure out if there's some variable that hasn't been set correctly. This is just great for debugging. So that's one bit there. But let me kill that. And let's try something else in my sources tab, which is the ability to do asynchronous call stacks. So I'm going to set a breakpoint and see in my call stack here, I only have two steps. This is because I'm inside of an anonymous function. So the browser is unable to tell me, what called this anonymous function at any given time, because it's actually been deferred. This would happen if you called set timeout or a request animation frame. So it doesn't give you the context about what set off that chain of events because it's been delayed. Well, if I check this async box on the call stack, and I try that again. Oh, I took away my breakpoint. Now I get not only those first two anonymous functions, it tells me, hey, this was actually called from set timeout. And now I can dig into exactly what called set timeout. So that's extremely helpful, again, for debugging your JavaScript code. So again, there's about 8 billion other features for Chrome DevTools. I could go on and on tonight talking about stuff, but I want to get to the meat of the presentation and really go into how to build DevTools extensions. Because again, just because your tests pass doesn't mean your application works. Just because Chrome Developer Tools doesn't throw any errors in your console doesn't mean your application works the way it's supposed to. And quite honestly, just because Chrome's Developer Tools does such a good job at understanding the code. I mean, things like the asynchronous call stacks are awesome, but that has literally nothing to do with my application. I don't understand any of the higher level abstractions. And in my case, I'm using either Sencha Touch or EXTJS to build apps. Chrome Developer Tools doesn't understand those frameworks, so it's up to me to dig in and figure out what's happening. So building our own Developer Tools extensions allows us to intelligently gather information about the applications we're inspecting. And the architecture for a Chrome extension has 3 parts. There's the inspected window, which you see in the upper left in my diagram. That's physically the application that's running in the browser. So in my case, that's my Sencha Touch app. And your Chrome extension can run code in the context of the inspected window. And that happens in one of 2 ways. I'm going to get to that in just a minute. But then there are 2 other parts that are more directly part of the Chrome extension. There's your background page. The background page does what it sounds like. It kind of sits in the background. It launches the extension. And it doesn't really do much unless you're specifically telling it to do something. But it can communicate with the inspected window via the post message API. So you can post messages between windows in that sense. Then there's your DevTools page, which is the code that actually runs inside the context of Chrome Developer Tools. And again, the DevTools page can communicate with both the background page and the inspected window via either post message or, of all things, eval. So one topic we'll get to in a moment is security, because as we all know, eval is the most amazing tool known to JavaScript developers. And there's variations on what you can do in the DevTools page. You can either add your own panels or you can append functionality to existing panels. There's a pretty good amount of information out there on how to build Chrome extensions, but once you get beyond the basics, it's really kind of up to you to hack things together. Even Stack Overflow doesn't have a ton of stuff. I don't get the impression a lot of people do this. So the background page is what happens, the background page launches your Chrome extension either when the browser fires up or when you enable the extension inside of Developer Tools. That only happens once. So that's important to remember, as your Chrome extension lives across every tab that's open in the browser. The background page lives and manages all of those instances, whereas the DevTools page is one instance per tab. So there could be many DevTools instances, but only ever one background page. So that's kind of interesting. Again, the inspected window is the application you're building. And in order to talk to the inspected window, you either use post message or you use one of the Chrome APIs for eval. They have a very specific API for that. And then last but not least, there's your DevTools page. And the analogy I like is this is a chart that I absolutely love. So imagine you're building an application that equates to either a dog or a cat, right? And so Chrome DevTools will tell you, hey, your cat has 4 legs and your cat has claws and it's missing an eye. But Chrome DevTools can't tell you where to pet the cat, right? Because that's business logic. And so you probably can't read this, but when you're petting the dog, dogs are to be pet anywhere. When you're petting a cat, there's like 2 spots on the cat, or else it tries to bite you. So that's a really funny mem. To better explain this topic, because the Chrome extensions are really conceptual. They're hard to explain unless I'm giving you a concrete example. So I'm going to show you the extension that I built for Sencha, which is an open source project. Code's available on GitHub. It's free to download and install. So you're more than welcome to fork us, take a look at the code I've written, totally rip it off and build your own. I would prefer you didn't, but the code's open and available. Actually, before I show you the architecture, let me just show you what our extension does, since many of you seem to be familiar with Sencha at this point. What I've got here on the left side is the XJS kitchen sink, which is just our cluster example of everything our framework does. And in Chrome DevTools, I have a Sencha tab, which fires up and tells me a lot about my application from the world of a Sencha developer. So namely, what version of the framework I'm using. In the Sencha world, for those of you not familiar, because you're building everything in JavaScript, you can kind of think of it like Spring or .NET, and that it's a very class-based approach to building applications. And so we've got what we call components. A component could be a widget, like a grid. It could be some arbitrary class that you use during runtime. But we can inspect the components used in the application, and much like the Elements tab, I can click on things and it will show me what component I'm interacting with in the sense. It tells me what X type it is, what properties or methods I'm using. In the case of XJS here, if I'm using MVVM and I've got data bound to these components, I can inspect the data that's bound to them. What's even cooler than that, in my opinion, is sorry, there's not enough space on the screen here. So I've got a number field that has data bound to it. I can physically inspect the binding, so I can see if I've screwed up one of my data bindings. Maybe I misspelled red because I put RUD. App Inspector will tell me that it was expecting there to be a data binding. It didn't get it, and instead it had something that existed it didn't expect. So again, Chrome DevTools won't tell me that. One of my other favorite features is we have a visualization that shows the inheritance chain for this particular component. So my number field extends from spinner, extends from text. I can walk all the way up the inheritance chain for this particular class. Now, Chrome DevTools, I could probably figure that out looking at my sources panel if I inspect a ton of JavaScript, but having this more visually present helps me as a Sencha developer figure this out. If I've got any data in my application, I can inspect each of the records and see what data is in those records. We've got utilities for analyzing if you're using the wrong kind of layout. So again, Chrome Developer Tools doesn't understand the XJS layout system. So if I'm using the wrong kind of layout, Chrome Developer Tools has no idea. But Chrome Developer Tools might tell me that I run into performance problems. The Sencha App Inspector will preemptively tell you, hey, you're using the wrong layout here, so you should probably fix that. So then you can avoid performance problems in the future. I can record events that happen in my application. And these are not browser events. These are component events inside the Sencha frameworks. So there's a bit of a difference there. And And then, since the XJS and Sencha Touch frameworks support MVC and MVVM architectures, if you're using anything related to MVC, we have ways for you to inspect your controllers, see what event listeners are bound where. So it's, again, all kinds of stuff that developer tools from Chrome doesn't give you out of the box. So now that you know what App Inspector is and how it works, let's look at the architecture. We have the inspected window, again, that's my XJS or my Sencha Touch application. The background page just launches my extension either when Chrome first loads or when I enable it inside Developer Tools. And then finally, DevTools page is the actual thing you saw in Chrome DevTools. And just as a side note, we built App Inspector using the Sencha frameworks. So we drink our own champagne in that sense. To really dive into how you build a Chrome extension, the first thing you have to wrap your head around is the manifest.json file. And there's a variety of things in here, namely like the name of your application, who worked on it, if there's a website for it. Has anybody ever built a Node.js package? A couple people. Okay, so it's very similar to your package.json in npm. But the two main bits I want to highlight are relating to security, where your Chrome extension forces you to tell it what permissions you want to grant the extension. So there are things like script source and object source for permissions. In my case, I want to say that my Chrome extension can talk to the tabs that are available. That I want to use context menus within the application, or sorry, context menus within the inspected window, and that I want my extension to be able to talk to any URL. So thankfully you all know and trust Sencha, because otherwise you'd be opening yourselves up to a potential security hole using my extension. We're benevolent dictators in that sense. We don't actually do anything wrong, but as you go to develop your own extensions, you have to keep these things in mind. You also have to keep this in mind whenever you install Chrome extensions in general. You don't actually really know what they're doing under the hood, but when you go to the download page in the Chrome Web Store, it should tell you what access they're requesting. Very similar to like your iOS store. It'll tell you, this wants to access your contacts, or it wants to access your camera. Same sort of thing. So there's the background page, and I mentioned earlier, the background page just kind of sits in the background. It doesn't do much. And in my case, for the App Inspector, that's very true. The only thing I actually do is I monitor for page refresh so that I can refresh App Inspector and thereby not force you to close and reopen DevTools. This is an interesting thing to communicate, because the background page, like I said, runs across every tab that's open. And if you're like me, you've got about 60 tabs open in Chrome. And you have to be able to say, well, tab 37 refreshed. Let's post a message to the DevTools panel in that tab and refresh App Inspector, because I don't want to refresh App Inspector on either tabs. So that's a curious thing to have to manage there. The DevTools page, again, this is the bit that runs inside of Developer Tools. For my Chrome extension, we actually have two parts. And what I showed you was the App Inspector panel. I didn't actually show you the Elements panel, because I forgot. Where if I go to my Elements tab, and I highlight down here where I've got my styles, event listeners, DOM breakpoints, and properties. I've also got this other tab called Sencha Component. And if I actually clicked on any bit in the DOM that is the root level DOM for a Sencha component, I can now inspect that object directly in my Elements tab. So again, not only can you create new panels in DevTools, but you can also append functionality to existing panels. So that's really very useful. Caveat, though, is that you can only do that to certain panels, like Elements. You cannot, as far as I know, add things to say like profiles. I would love to create a Sencha profiler, but I'm not given access to that. Then there's the inspected window. And as I mentioned, there are two ways to communicate with the inspected window from a DevTools page. One is post message, which, has anyone ever used the messaging APIs in the browser? They're about like the ugliest thing on the planet to have to deal with. And when you're trying to run code within the context of another window, there's all sorts of security blockers there, so even if I wanted to use post message, I'm pretty sure I couldn't. So, and what I mean there is that you need to pass strings back and forth, and so if I wanted to execute an eval code inside the inspected window using post message, I don't think I actually could. So there's an API called chrome.devtools.inspectedwindow.eval, which is exactly the same as your just native eval function in the browser. And that's exactly what I have to do with App Inspector to inspect the application. So just a quick look at what I'm actually doing. I've got my own library sitting on top of the Chrome APIs, which does a variety of things, but you can see here, I'm basically calling Chrome DevTools inspectedwindow.eval. I set a string which gets evaled in the context of the inspected window. So, some closure, some function that I arbitrarily define. I wrap that and then pass any arbitrary arguments to that. This entire thing gets evaled. But rather than returning a string when that executes, it actually returns to me an object with whatever results of my evaled function, or an exception. And so if there's an exception, I handle it using my own API. But assuming it passes back a result, again, from way back up here, I passed in a callback function. I then call my callback function with the results of whatever was evaled. So that's how everything in my Chrome extension works. There are some interesting. Oops, that is not what I wanted to hit. Let's start the presentation over. Okay, so there are two curious use cases that involve eval. So when you think about what I just showed you, I'm evaling arbitrary JavaScript in the inspected window. That's a synchronous operation that returns a result. Happens one time and done. If I want to do anything else, I need to call eval again. So what happens when I need to do like a long-running operation? Like maybe I'm monitoring the application for events, or if I'm monitoring layout changes using the XJS layout system. These are things that are not going to happen synchronously. Otherwise, I block all execution for the application. What you can do is part of the closure you pass into eval, you can set off something like request animation frame or set timeout, and have that continue to run, popping data into some local variable in the inspected window. So at this point, I've now altered the runtime of the inspected window. That's, let's make that clear. But then the next time you call inspectedWindow.eval, you could stop the animation frame or stop that set timeout, and then return the data it was caching locally into my DevTools page. So, it's sounds like a hack because ultimately it really is, but that's the way Chrome has twisted my arm into building my extension. So a couple of links. You don't have to rush to write these down. I will make these slides publicly available later tonight on the meetup pages. But there are 3 links here. The first is the index of Chrome developer tools, so you can learn more about developer tools in general. But as I said, their documentation is really kind of slim. You're better off searching YouTube for some conference talks on some of the more advanced features. If you want to build your own DevTools extension, that's my second link there, developerchrome.com, extensions, DevTools. And then lastly, if you're really interested in learning more about what I did with App Inspector, you can go to the Sencha blog and find out what I did there. That was posted maybe 2, 3, 4 months ago. There's a video as part of that, so you can really get a deep dive into more about Sencha App Inspector. And I am free to field questions now. I bored you all to tears. Anyway, questions back.
You can do this if you're using Google and IE or something like that.
I didn't quite understand if I'm using Google and.
You're using Google and I'm in IE.
Oh, so right now the way you build Chrome extensions is very similar to how you might build an extension for Firefox or Safari. I don't know with the latest versions of Internet Explorer, like IE 10 or 11, if they allow you to build extensions. I haven't actually tried that. So conceivably, if you can, you'd build them in much the same way, although some of the APIs will be slightly different. The content security policies will be slightly different. But you couldn't just drop my extension or use my extension to inspect something in IE right now. I've done some research into building extensions on other browsers or other platforms, but I've never tried an IE only because I've never looked past IE 9. So 10 or 11 are supposedly really good browsers. I just don't know much about them under the hood. Other questions?
You talked about memory issues on Chrome using heap. Is the popularity of Chrome due at all to its efficiency and memory use compared to the next one would be IE and Firefox?
I would say that was probably the case up until very recently. That would be my guess as to why Chrome has become so popular, because going back to 2008, at that point I think maybe we were on IE 7 and Firefox 3 and probably Safari 2, something like that. And certainly Chrome then, and for a couple of years after that, was light years better in terms of managing memory than those browsers. Today, I'm unconvinced that Chrome is any better than any of the other browsers. Firefox in particular is phenomenal. Their developer tools have come a long way as well. So for any of you still using Firebug, if you're using the latest version of Firefox, you don't even need Firebug anymore. So Chrome's got some really cool stuff relating to memory management that other browsers don't. I didn't dive into this because, quite honestly, I'm not nearly smart enough to talk about this in anything. But if you do Chrome:// tracing, and forget what I need to do here.
Who are Sencha competitors on Chrome? And what are the competitors in IE and Firefox?
For the extension, you mean, or?
Well, I gather Sencha has competitors with using Chrome.
So in terms of the products Sencha makes are cross-browser. So if you're using XJS or Sencha Touch, your application will run on any browser. In terms of the Chrome extension, we don't really have competitors in that sense. There's one tool on Firefox that's called it's Illuminations for developers. But that's not specific to Sencha. It helps debug Sencha apps, but it also does jQuery, YUI, Dojo, and a handful of others. So from my point of view, developing this extension, I don't really view us as having competitors only because I don't feel like I'm competing. This is just a tool that evolved out of a project that I started because I needed a tool. I know in other frameworks, if you're using Angular or Ember, there are Chrome extensions similar to what I've put together for Sencha. The last time I looked at them, they weren't nearly as robust, but they may not need to be. I'm also not an Angular or an Ember expert. So I'm not sure if that answered your question, but if you're really curious about browser memory optimization, check out Chrome tracing. Do a couple of Googles on YouTube for how to use this thing, because this thing doesn't talk about JavaScript. This thing talks about like memory allocation at like the binary level. If you're using things like CSS3 transforms that transfer all of that into the GPU, you might look here to see if you're overclocking your GPU, or I'm just shouting out buzzwords now because I honestly couldn't tell you how Chrome tracing works, but it exists and it's really cool if you understand it. So that's a feature no other browser has. Other questions? Race client, okay. Well, feel free to grab me afterwards here. What I want to do is to raffle off a couple of prizes. Like I said, you had to have RSVP'd on the Milwaukee JS meetup to be eligible for the raffle tonight. So I'm hoping all of you did. And what I have here, this is probably the most terrible example of a Sencha Touch app I could come up with, but it serves my needs. This is an app that connects to the meetup.com API. And so we can see it's listing all of the upcoming events from Milwaukee JS, which is just us tonight.
Yes. You want to give speaker suggestions or topics you want to talk about? We're open to hear them at the moment. We actually don't have anything scheduled. So I figured have stuff side that I know people want to talk about, so we'll reach out to them and see if we can get those up soon.
Yeah. So what I can do, I can tap on this and it'll show me everybody who's RSVP'd yes for tonight's meeting. You must be present to win. The way this app works is I have a really very simple random number generator that picks a number off of 0 to however many people RSVP'd, grabs that ID, I pop up the winner, and then I take you off the stack. That's all this does. So for example, Josh Dean, are you here tonight? Charlene. Hi, Charlene. Okay, so you have your choice tonight. First in mind, you can have either a Sencha t-shirt that looks just like mine, a book called EXTJS in Action, a t-shirt from one of Sencha's partners called Modus Create, a USB power station, so you can power your phone on the go, or some Sencha green tea.
Hard choice.
The book. I'm going to pass that back. All right. Thank you for coming tonight. Okay, so now Charlene's out of the running for another prize. I'm going to butcher this name. Yoya? No? Okay, good thing you're not here. If you're listening, Yoya, sorry. Luke Jeter?
I will
You already,
try to charter.
all right. You already have your Sencha t-shirt, Mark? Thank you for coming, sir. Jordan. Jordan, no, okay. Gabriel?
Oh, that's me.
All right, what do you want? We got t-shirts and green tea.
What's that for the t-shirts?
Medium. I think they're all medium.
Oh, I'm not medium. Okay. Also, we can get you a t-shirt. Tea?
Tea. Here you go, sir. So that's not really a random prize, by the way. Sencha is actually a kind of green tea. So we chose our company name off of the really weird Silicon Valley paradigm of naming things after teas, like we're caffeinated products like Java. So Dustin here. Wah, wah. Angela. Oh, Angela. Okay. Tony. Sencha or Modus? There we go. So we have one more Sencha and one more Modus. Omar. Oh, you're going to pass. Okay. In case you're curious, Omar is the co-sponsor of the Milwaukee Sencha meetup. So he's kind enough to co-sponsor the event tonight. So if you want to come see more about Sencha, we have a meeting.
About a month from now, we're going to be talking about using Sencha with mobile backend of the service. So a couple different providers, how to integrate Sencha with various cloud services.
And where is our meetup?
That is going to be in the Third Ward at the Hudson Business Lounge.
So come join us next month to talk more Sencha.
I think, again, that's a Tuesday at 6 p.m. if I recall.
Okay. So check out the Sencha Milwaukee user group on Meetup, and you'll see our upcoming meetings.
There's a link to it on this meetup's description.
Thomas? Man. Patrick Lee. All right. Sencha or Modus t-shirts? All right. Okay. Graham. All right. So you get a Modus t-shirt by default. Here you go, sir. Thank you guys for coming. Stick around, drink beer, talk tech. Anything else you want to?
No, I think we're good. Sorry about the technical difficulties. I blame Dustin.
Raffle off the pizza.